Hi guys, welcome to LTS webinar. Thank you for joining. And before we start, I would like to describe our Q&A modality for you, how you can ask questions and communicate with our speaker during the webinar. So, okay, at the bottom of your screens, you can see two icons, chat and Q&A. Our today's speaker is Stanimira Vlaeva, and maybe she will ask you some questions during the webinar, and you can use chat to to answer these questions and to give your feedback. But if you want to ask more complicated question, please use Q&A icon, type your question there, and Mira will choose the most interesting questions after her presentation. So thank you for joining again, and please enjoy the webinar. And now I'm passing the word to Stanimira Vlaeva. Mira, please share your screen.
Hi everyone, I hope you're doing all right and that you can see my presentation. Our topic today is pretty interesting, in my opinion, of course, but I chose it. So the topic is supercharging Angular libraries with ngadds. First, a few words about me. My name is Stanimira Vlaeva. I'm from Bulgaria and I work at Progress. I work on a very interesting project called NativeScript. But today we're not going to be talking about NativeScript. We're going to talk about the Angular CLI. And first, I want to present you the most awesome Angular library that I have ever written. And it's not NativeScript. Let me show you really fast. I'm just going to demonstrate it for you. So I have a workspace here with the library itself and a demo application. And I'm going to start the demo application, and you're going to see the most awesome Angular library. Ready? Ta-da! It looks amazing. It has just a single component, and it says catch name works. It's totally not the out-of-the-box Angular library that you get when you generate a new library within the Angular CLI. But what is more interesting is how do you actually start using such a library inside your Angular application. So as I said, I have a couple of projects here in this workspace. I'm going to share the GitHub repository later. So the first project that we have is the library itself. It has a pretty catchy name. I have a demo application that I'm using the library inside it, and that's what we're going to see now. That's the demo application. And here we can see a pretty simple Angular setup. We have a root module, and we're importing a catchy name module. That's actually the Angular module that our library exports. And once we import that catchy name module, we can use the component. That is the simple component that we saw earlier. It looks pretty simple, but there are actually a few steps that you have to do in order to start using that library. The steps are described in the README, as it's pretty usual for any Angular library. So here's what we need to do. We need to install the library that saves it as a dependency in the package.json. Then we need to import the module, and so we can then start using our library. But that is a very simple example of a library, isn't it? What if we wanted to use Angular material? It's actually, the setup is pretty similar. Or if you wanted to use Angular Firebase or Angular Fire, the setup is pretty similar, but it has a few more steps that you need to do. So you saw a very nice library, but the setup is kind of tedious and it's kind of repetitive for most of the Angular libraries. Can we actually automate that setup? Can we make it in a way that our users just run a single command and then they can start using our library? And there is a pretty cool command that's new in the Angular CLI. And by new, I mean that it has been around for almost a year now. And it's called ngadds. Ng comes from the Angular CLI. If you're familiar with Angular itself, you're probably using the Angular CLI. So ngadds some library, where some library is obviously the name of the library, does a few things. First of all, it installs the library package. It uses npm or yarn or whatever npm package you have set up on your machine. Then it executes schematics. And here things start to get a bit interesting because schematics may be a new word for many of us. But don't worry, I have a pretty nice definition for schematics. So I'm just gonna read it and you're gonna understand everything about schematics. So schematics is a project transformation tool for scaffolding, updating files, executing tasks such as npm install and git init. And if you're like me, then your first reaction when you heard that is, what is that? But don't worry, I have a few examples that I can show you and everything will become clear. So for example, if you run ngGenerate component, and then we provide the name of the component, the command does a few things. First, it creates the component files, the class, the template of the component, the style for the component. And another pretty important thing is that it registers our component inside an ng module. In our case, it updates the app module and adds the about component in its declarations. Another example, if we run ngadds native script, that does a couple of things. It installs a few dependencies that are necessary for native script. It creates a bunch of native script specific files, updates your package.json, for example, to add the new dependencies. It also updates your app module and a bunch of other things. So this is it, pretty much. If you're using the Angular CLI, you're already using schematics. So a couple of commands in the Angular CLI that have to do with generating files or moving files around or installing node modules, they all use schematics under the hood. So an example of these commands, as we saw, are ngGenerate, ngadd, ngupdate, or even ngnew. When you're creating a new project, you're executing some schematics. And today we're going to learn how to create our own schematic collections to make our libraries ngaddable, so that we can run ngadd, then our library name, and then the Angular CLI can execute some setup logic for us. But first, a little bit of theory. It's really just a little bit, I promise. What is schematics? The most important thing in the schematics dictionary is the tree. So the tree consists of two parts. The first part is the base. You can imagine the base as just a virtual representation of the directory that you're inside. So if you run your command inside my project, or your project in your case, the base contains all the files in that project, including all subdirectories and the files in these directories. And the thing is that you can read these files, you can see what's the structure of the project and stuff like that. And the other pretty important thing about the tree, it has a staging area, or something that I call actions. So the actions tell the tree that a couple of stuff should be done. You should modify the package.json, for example, to add a new dependency. You should create some file. You should move one file from one folder to another. So okay, that's the tree. It has a base and it has some actions. And the other very important thing about schematics is the rule. A rule is just a function that takes one argument, one that's important for us right now. That's a tree. And when we start the command, usually the tree is just has no actions, and it has a base that's exactly the same as our current file system. And it returns, you guess what? It returns another tree. And the tree may be modified. It may have some actions inside it. And what schematics does, it validates these actions. That's pretty important. It makes sure that these actions won't cause any problems to the files in the base. It takes them one by one. It checks what happens if I modify that package.json. Okay, everything is cool. What happens if I create an app module? Okay, everything is cool. And then after it have validated the rules, the actions, I'm sorry, it actually applies them to the real file system. So that is pretty important, and we'll see in a moment why. So what are the benefits of schematics? So far, I just said that we have a bunch of files and we apply some actions on them. Why don't we just use the Node util modules like fs or read file and just modify our files with Node, and that's it. First, because with schematics, we get something called atomic updates. Let's imagine what will happen if we didn't have schematics and we used just the Node modules to update files. First, we try to modify the package.json, and that is okay. The package.json is modified. Then we try to create a file in the source folder with the name app module. But that will give us an error because such file already exists. And that is not good because package.json is modified. And we actually wanted to run this thing as one action. We can't roll back the change. Instead, we, of course, write some custom logic to roll back the package.json. And with schematics, we have an action, then we have a second action, then schematics, the schematics engine or library validates these actions. It sees that the actions will cause an error, and it actually discards all of the changes. And in that way, the package.json is not modified. And this is good because we can say that the whole transaction is discarded and we haven't modified anything. So for example, if you try to create a new project with ng-new something something, and I don't know, let's see as an example, you have a bunch of files that are already there in the same folder, and the project cannot be created, no new files will be generated. I didn't explain that very well, but okay, another example. Pretty simple. We want to modify the package.json by installing a new dependency, and then we want to use that dependency by creating an app module. But we don't want to install the package if we already have an app module. And that is cool with schematics because we won't update the package.json because the second action will throw an error. Cool. So another pretty important thing is that schematics are declaratively written. They're not described in some JSON or whatever. They're written with TypeScript or even pure JavaScript, but let's just say that they're written with TypeScript. And that gives us a lot of cool things. For example, we can reuse different schematics. We can distribute schematics as node packages, and other people can use them. Also, schematics are pretty easy to unit test because they don't need the actual file system. And the most important thing, the schematics are composable, which is pretty cool, and we may see that today. Cool. So what are gonna be our goals today? We want to write ngadds catchy name. Catchy name is the name of our library, and that should install the catchy name package. Actually, schematics, no, not schematics, but the Angular CLI does that automatically when we run ngadds and some module. Then we want to add a dependency to catchy name inside our package.json because the Angular CLI won't do that for us. And the third thing, we want to import the catchname module inside our root app module. Cool. So first, how do we get started before we actually get started? In order to generate new schematics, you need to use the schematic CLI. I mean, you don't have to, but it's really easy that way. After you install that package, you don't have to do it now, you can do it later. You can run schematics blank. Blank is just a collection. And then provide a name for your schematics collection. And that will generate a new schematics project. Maybe just a second to explain the whole thing with the collections. When you use the Angular CLI and you type, for example, okay, let me open a terminal, ng generate component and provide some name, you will use by default the schematics Angular collection. These are the default schematics that come with Angular, and they're obviously schematics for generating components, modules, classes, and a bunch of other things that are important for your Angular module. But there are a couple of other collections out in the wild. For example, there are collections for generating ngrx things like reducers or actions or whatever ngrx things there are. There are, of course, schematics for native script that you can use to generate native script specific things. An important thing is that when you use ng-generate, that is not directly important for ngadd, but if you want to specify a custom collection, you need to provide it like that as an option. Collection, and then type in the name of the collection. Okay. And when you run ngadd and the name of some library, for example, catch name, the Angular CLI will try to find a schematics collection inside that library. And that is cool. That means that we need to bundle our schematics collection inside our Angular library and publish it inside the package. Cool. So these commands that I showed you, I have actually already used them inside our little workspace here. And as I already showed, our projects are inside the projects folder. And here we have a schematics folder. So we're going to be using the schematics folder intensely today. This is where we're going to add our code. And then we're going to build that folder and just put it inside our package. But that's going to be the last thing that we do today. Cool. So I have modified a few things that are usually generated by the Angular CLI, but they're all described and we'll go through all of them. Okay, the most important file in our schematics project that we have generated here is the collection JSON file. It is inside the source folder, collection JSON. Cool. This is a JSON schema that describes our schematics. This is the name of our collection. It's a bit misleading because it's called schematics, but it can as well be called catchy name schematics or whatever. Okay, so we have a single schematic here. And for now on, I'm gonna call these simple schematics just rules because it's easier to call them that way, although it's not totally correct. And that rule is ngadds. So this is very important. The name should be ngadds because when you type in ngadds and the name of the library, the Angular CLI will look for a rule that's called ngadds. Cool. We have some custom, some default description here, and I'm gonna change that to, for example, sets up catchy name library. Cool. And the other very important thing is that we have a factory function here, or more like key value, something that points to our factory function. Let's see what's our factory function. It's inside ngadds, index, and the ds here denotes that we're going to be looking for an exported variable or function or whatever with the name ngadd. And that is our exported function here, ngadd. So this is a factory function that returns a rule. Why do we call it a factory? Because it returns actually another function. This is our rule that we discussed earlier. It accepts a single argument, that's the tree, and in our case, it returns the same tree. Cool. So for now, we are not really doing anything, right? We just modified the collection JSON to say what's the description of the library, and we're pointing to our factory function here. And I'm gonna take a little bit different approach today, and I'm actually gonna start by writing a unit test for our schematic. And this is actually what we're gonna be doing. We're gonna be writing unit tests, and then we're gonna be making them pass successfully. And with schematics, it's very, very easy to write unit tests. Okay, we have a bunch of things here imported. I have modified again the default generated unit test a little bit, but we'll get to it. So we have our the path to our collection here, and we have a single unit test. If you're not familiar with Jasmine, that's the unit test runner that we are using, don't worry, it's pretty self-descriptive, and we're gonna explain everything. So the most important thing we have is that before each test runs, first, we're gonna create some test app. And this is a very important step when we're writing schematics for some Angular libraries or Angular applications. The create test app function does a bunch of things. We're not gonna spend too much time on that, but first it creates something called a schematic test runner. And this test runner is very important because it doesn't actually use the file system. It executes our schematics, how do I say it, on some kind of a virtual file system or an empty tree structure. And what we get is a tree, just a tree, but we're not actually applying the changes in the tree at the end. Okay, so using our base runner, in order to get our really basic Angular application that we're gonna use in our unit tests, we're calling some external schematics. And this is a very important thing in schematics because you're gonna use it a lot when writing Angular schematics. Cool. So we're running an Angular schematic from the collection schematics Angular. That is the default Angular CLI schematics collection. And from there, we're getting the workspace rule. And that rule actually creates a new Angular workspace, which looks a lot like an Angular application, but it actually can host a lot of different Angular applications inside it. And then we are providing some options. The options are not that important. Okay, we have a workspace, and then we're running another schematic. Again, from the schematics Angular collection, we're creating a new application inside our workspace. And here we're providing the name from the for the application. And so another important thing is that we are running that on top of our workspace tree that we created. And that will give us some basic setup, right? So I'm gonna put a breakpoint here, and I'll try to execute that test so that we can see what's inside that app tree. Okay, our app tree is of type unit test tree. We have some actions, but we're really interested in the files. So the files that we get resemble the usual files that we have in some Angular application. but they're actually inside the workspace. So in that workspace, every application is inside the projects directory. And we have a single application that's called My App. That's the project name that I'm providing right here. Okay, cool. We have our basic setup. And the idea is that we're gonna run our ngadds schematic on top of that tree, so that we simulate a real Angular application. Cool. The next thing is that we do, we create a new test runner, and then we execute our schematic. That's ngadd. That's pretty important. The name here should match the name inside the collection JSON. Cool. And then after we get that tree, we can expect that it contains some files and some files that, yeah. Okay, I'm just gonna stop that test. I stopped on another breakpoint and we can see what we have in our tree. So the files in the tree are pretty much the same because, as you remember, our schematic currently doesn't do anything. So that's why this test will fail, because it expects that the tree files equal an empty array. And that is not true because we already have some files here from our basic setup. We can see in the console just to make sure that it failed. Awesome. Okay, but that test doesn't really do anything interesting. I'm gonna go ahead and write a more meaningful test, and I'm gonna call it adds dependency to catchy name library. So how do we expect that to be true? First, we need to get our package.json. The path to our package.json file should be just package.json, and it should be at the root level, right? Then you can use a pretty cool utility function that only the unit test trees have. And that is tree.readContent. And we can provide the path of the file that we want to read. And what we get here is a string. So now we have the content of our package.json. But a string doesn't really work for us. That's why I'm just gonna go ahead and parse that string to a JSON, to just a JavaScript object, obviously. And then I will expect that my package.json has a dependency to my library. And the cool thing is that I have written an utility module, you can call it, which has some info about my library. We can see it here. Package info, the name of my library is catchy name, and the version that I want to add right now is 001. Cool. So I got the name and the version. And now I'm going to expect that package.json. I don't have any autocomplete right now because actually that thing is of type any. But the other cool thing is that I have some interface called package.json. That's very simple. You just have dependencies and dev dependencies just to prevent me from making typos. So let's go ahead and, yeah, from the dependencies from the package.json, we want to expect that the name of our library equals the version that we want to add. Cool. That's our pretty simple test. I'm gonna run it. And we can see that it fails because currently inside our package.json, we don't have our library. Cool. Another important thing that I forgot to mention is that because we are running, we are writing TypeScript here, we should compile that TypeScript files. And here I have a project, a process running that just uses the TypeScript compiler to compile my files every time I change something. That's really important, obviously. Cool. Now let's make that test pass. I won't type my code here because it will get messy pretty easily. So I'm gonna get another function that's called @dependency. And here I'm just gonna pass in the name of the library and the version that I want to add. And of course I want to return a rule. As we already know, a rule is a function that takes a tree and returns another tree. Awesome. Okay, what I need to do is get the package.json. So I already know that the package.json path is package.json, right? And then I should get it from the tree. But here I don't really have the read content method. That's important because the read content method, as far as I know, is available only on the unit test tree. So I'm gonna go ahead and add another function here that's called getJSON and accepts some tree and a path. And yeah, I just call that random because I'm not sure what I'm gonna get. And the tree has a cool method called read, which accepts a path and it returns a buffer. So that's actually a file buffer. But another important thing that we should notice is that it can return null if we don't have such path inside our tree. So we should check for that. If you don't have a file buffer, I'm gonna go ahead and throw new schematics exception. Yeah, we can say that the file, or maybe cannot read file at path. And pretty much that's it. We can't do anything if we can't read that path here. Cool. Now that we know that our buffer surely has something inside it, we can just convert it to a string. But as we know, our package.json is a JSON, so we need to actually parse that string to JSON again. But of course that can also fail, so I'm gonna wrap that in a try catch, and I will try to parse the content and return a JSON. And if that fails, again, I'm gonna throw new schematics exception. So the reason that I'm throwing a schematics exception and not just a normal error is that the Angular CLI, or yeah, in our case, the Angular CLI will print that error pretty beautifully, and it will skip the stack trace, or it won't show as much stack trace as we don't want to see, or our users don't want to see. Cool, so we can say here, couldn't parse file at path. And we can actually show the original error that we got. Awesome. We're returning the JSON. Another cool thing that we can do, because this is a JSON, it's an object, we can make it generic and we can return the type, or return the object as a type. With that said, we can get that package.json with the getJSON function, and we can say that this type package, no, not package info, but package.json. Cool. We're providing our tree and the path. Awesome. So now we have our package.json. And what we need to do is add a new dependency. So I'm gonna make a copy of the existing dependencies. And how do you make a copy with ES6? You can just spread that object here. And another important thing is that I don't want to overwrite the version of the library if I already have a dependency to it. So I'm gonna check if the new dependencies, or actually in our case, still the old dependencies, have package info.name. I'm just gonna return the old tree. Cool. And actually I'm gonna extract that name and version again, just like I did in the unit test, so that I can use it. Why do you complain? Because it has some, oh yeah, sure. I'm actually getting the name and the version from the arguments of the outer function. So I won't spread that here, but I'm gonna provide it later or before invoking that function. Cool, so if you already have a dependency to that library, we're not doing anything. And if we don't, we're gonna add a new dependency. And our new package.json is gonna look just like the old package.json, but it will have different dependencies. Cool. Now what we should do is we need to overwrite the file inside our tree. We're adding a new action here by using the tree overwrite method. So we need to specify the path, that's our old package.json path, and the content. So I can just type in that, new package.json. No, I actually can't, because the second argument should be, okay, we can't really see that here, but okay, the second argument, the content should be of type string or buffer. So this thing is a object. I'm gonna convert it to a string. And in order to keep it pretty, I'm gonna say that the indentation is 2 spaces, because that's the standard indentation for a package.json file. But if someone have modified their package.json to have an indentation of 4 spaces, that won't be good. But that's why you should keep to the standards, right? Okay, we have overwritten our package.json, and we can put a breakpoint here, probably, and see what happens. But of course, first we need to start using that add dependency function. So instead of that rule that does nothing, I'm gonna return a new rule by invoking our function. But first I need to get the name of and the version of the library. What was it? Package info. Cool. Name, version. Nice. Let's see if we managed to get inside here. We didn't. Yeah, we didn't really manage to get inside, but we see that the unit test is passing. But I'm stubborn, so I will try to force that by adding a debugger statement. Hopefully that will work. I really want to see what's happening step by step. Yay, cool. So we're getting our package.json. We can see that it has the usual things that any Angular application does. It has dependencies to Angular, has some dev dependencies and stuff like that. Then we are getting the new dependencies. We can see that. The new dependencies, which at the moment look like the old dependencies. We don't have dependency to catch a name. So we're adding a new version. We're updating the package.json. You can see that here, that in the dependencies, now we have catchy name. And then we're just adding a new action to our tree. Let's see our tree. Yeah. Then some weird stuff happens inside schematics, and our action is applied and the unit test passes. Cool. Okay, let's go ahead. What was the second thing we needed to do? We wanted to be able to add our ng module, the catch name module to our root module. So that's what we're gonna check. Imports the catchy name module in the root module. So first, we need to know which one is our root module inside that test application that we created. So the root module path is, I actually have no idea. So we're gonna pause here and we're gonna inspect our tree. We don't really need that debugger anymore. Let me quickly remove it. Hopefully. Cool. So that's our tree. These are the files, and we're looking for app module. And our app module is right here. I'm just gonna go and copy that path because I don't want to type it. And cool. Let's stop this test. Let's grab the content of the root module, again with 3 read contents, root module path, and then what we need to see here. So we need to have an import for our catch name module. And the imports should look like that. Import catch name module from catch name. Cool. And actually, we just need to expect that the root module contains that JS module import. Cool. So far, so good. And there's another thing we can check, but probably I won't have time to cover that. You can try doing that at home. We need to check that the ng module is imported in the root module metadata. That means that we need to have something like that. ng module, not really that. Okay, I'm just gonna go ahead and show it. We need to have that import here. Let's copy that in the to-do because we need to know what we're missing. Cool. I'll just get rid of the extra stuff. And maybe we can check that later if we have enough time. Cool. But so far, so good. We can actually run some end-to-end tests later to ensure that this works as well. For now, we are checking that our catch name module is imported inside our ECMAScript module. Cool. Of course, our test failed, which is a good thing, because if it didn't fail, that means that we haven't written the right test. Let's go ahead and just make it pass. So here things get a bit complicated. First of all, we need another rule, but we can return only a single rule from this function. Obviously, I can go ahead and type another function name and return that because we can return just a single thing from a JavaScript function. But we have something called a chain. That's a helper method from, actually it's a function, whatever, a helper function from Angular Dev Kit schematics. And what that chain does, it allows us to add different rules, which it then combines. Okay. It then combines these two rules and returns a single rule. So by cheating in that way, we can add a few rules inside our schematic. Cool. So I'm going to go ahead and add another function that's called import in root module. And again, it should return a rule. That is a function that receives a tree and returns another tree. Awesome. And then I can just go on and call that importing root module function. Awesome. Another important thing here, first of all, how do we know which is our root module? So in my test application, I just copied the path because it's fixed there, right? But the Angular applications out there in the wild may have been modified. We clearly know that in a new Angular CLI application, the path to the root module is source app module TS or whatever, but people may have modified that. So we need a more stable way to figure out which one is the root module. And luckily for us, inside the Angular schematics, there is also a similar problem. So whenever we are adding a new component, we need to update some module. So there should be a stable way to know which is the root module. And there is a function there that helps us do that. Actually, there are a bunch of functions. And I have added a simple utility function that combines them. And we're going to use it. So our root module, we're going to fetch from find root module. And we need a tree, and we need our project name. For now, I'm just going to say that my project is called my app, and later we'll figure out a way how to get a real variable here. But now let's go see what happens inside that root module function. Okay, hopefully, yay, we stepped on that breakpoint. So find root module, what it does, it uses, as you can see, 5 functions from schematic Angular, okay, 3 from schematic Angular, to find the root module. So first we need to get the workspace. And workspace is just a fancy word for our Angular JSON file. So for those of you who are not familiar with the Angular JSON file, every Angular CLI project has it, and it describes the structure of the project. And because we can have a lot of projects inside a single workspace, we have that projects dictionary. For example, we have one project for the end-to-end tests from our app, and we have another project for the actual app that we're going to run, the actual web application. And we also have a lot of options that tell the Angular CLI how to actually build that project. But we're not going to get really in depth in that. I'm just going to say that by getting the project here, we can then get the project targets. So the project targets, I hope you can see them here. We have different, how do I say it, configurations, what each Angular CLI command should do. For example, when we run ng-build, we're going to use some builder that the Angular CLI knows how to use, and we have some other options. And what is most important here is that our main path, that's the main.ts file, is contained here inside these options. So the main path is projects, my app, source, main.ts. So let's just go ahead and quickly see how a typical main.ts file looks like. It looks like that. Cool. So we have a bootstrapped invocation here that we're using to bootstrap our module. And as you can see, we are bootstrapping our root module. And by using that information, we know that when we find a bootstrap module call inside that file, the first argument will be the app module. And app module, of course, may have a different name, but when we find that token here, we know that we should find its import, or more specifically, the path that we're importing it from. So I'm not going to get into too much detail what the get app module path does, it uses the TypeScript API to parse the TypeScript file, which is main.ts, and then it does exactly that. Just in short, it finds the Bootstrap module call, then it gets that token app module, and then it finds the path from that we're importing the app module from. And when it finds that path, now we know that this is the path to our root module. Cool. We have our root module, which is app module, and now we can import stuff inside it, right? And for that, I have another cool utility function that I called import. Actually, I don't know how it's called, but it's inside AST-utils that you're gonna find later in the repo. It's called add module import to module. Yeah, I'm not too good at naming stuff, but it will do. So we need to provide the tree, the module to import in, that is the root module, because we're gonna import stuff inside it. The imported module name, that is catchy name module, and the imported module path. So which is the path that we're importing catchy name module from? That's the catchy name library. Cool. And that actually mutates our tree, so I don't have to reassign it. I just can run it again and see what we're doing here. Cool. So first of all, we are getting the TypeScript source file for that path, for that app module. And let's say that this is just another structure, another tree that contains all the, how do I say it, all the tokens or all the identifiers inside our source file. And then we can use another utility function from the Angular CLI just to make things easier. That's called add import module. And that import module uses the that structure, that tree, to add imports and stuff to it. Okay, so what's important here? I'm trying to oversimplify the modification of that abstract syntax tree, and I'm not talking about it on purpose. So we have some changes here. We get some changes. The first change is an insert change, which says that we should add a catchy name module to our metadata. And the other is, again, an insert change that says we should add an import to our catchy name module. So what we should remember is that we're using the add import module function, which is exported from the Angular schematics. We are grabbing these changes, and then we're creating something called recorder. So the recorder says to the tree that we're gonna update some file. And then for each of these changes, we are adding a new change inside our recorder. We're recording our changes in a way that later the Angular CLI can reapply them and make sure that they're valid. And then it can apply them to the actual file. So after we apply each change, we commit that update to the host. The host is just a fancy name for a tree. Cool. And pretty much that's it. Then we return the tree, which is modified. It has some recorded changes for some file there. And we can continue running the test, which passes. And that is cool. Okay, so there is just one thing here left. If you remember, we hard-coded that thing to my app. So how do we actually get the project name? We can have something like that. We can type in ngadds, catchy name, and provide the project name. And that's gonna be my app. But obviously we don't want to do that every time, and in most Angular applications, there is only a single project that we want to add. And in almost all Angular projects, there is a default project. So the Angular CLI has a solution for us. First of all, how do we add options to our schematics? We need to provide something like a schema. It's actually exactly a schema. So that's our prepared schema for our ngadds schematic. And the most important thing is that we have properties. These are our options. And we have the property project name, which is of type string. And by default, if we don't provide anything, we're going to use a smart default. The smart defaults are something that's provided by the Angular CLI. And the coolest smart default is obviously the project name. So whenever we use the Angular CLI to run that schematic, it's going to provide us with that smart default, the project name. It will actually parse the Angular JSON file for us. It will find the default project and it will provide us with that option. So we can pretty much use it out of the box. Cool. Another thing that's important is that we need to register that schema inside our collection. Cool. We are adding a new key called schema, and we're providing the path to the schema JSON file. Then we can use these options inside our factory function. I'm gonna add a pretty quick interface code options, and here we have our project name, which is of type string. And then we can just provide the options here inside importing root module, options again, and we can read the project name from the options. Nice. Another important thing is that we need to provide that default option inside our unit test as well. So the option, project name, we already have the project name. Cool. The only thing that's left is that we need to run the schematic with our options. And we are already doing that. Awesome. Running the unit tests again, just to make sure that everything passes. Yep, they work. All right, so there's just one final thing that we need to do. And that is when we build our library, we need to put our schematics inside as well. So just to spoil it a little bit, I'm building my library by using the ng packager. And before building the library itself, I'm gonna build schematics and put that inside the same folder. So here's another schematic, another npm script that's called build schematics, which will go to the schematics project, then build the library, and then I'm just gonna go ahead and copy the contents of the source folder inside this folder. Where is my where is the library itself? Cool. And before I build the library, I will want to build my schematics. Okay, let's see what happens. I'm running npm run build library. We are building our schematics. Then we're building our Angular package. And actually, I think that I don't have the right order of the commands, because whenever I build my library, it will actually delete this folder. So the build of schematics should be after the build of the library. That's important and totally intentional error. Cool, I'm building the library again. That takes just a little bit of time because of TypeScript. Cool, now I'm building schematics. And let's see what's inside our dist folder. Okay, we have our collection JSON file. That looks the same way as it should. And we also have our ngadds schematic. Nice. Another very important thing that we shouldn't forget is to add a reference to that collection inside the package.json. So we need to add a schematics key that points to the collection that our schematics use. But it's totally useless to add it here because that's the dist folder, and I should actually add it inside my library. Cool. I didn't want to do that. Awesome. Let me rebuild that really fast. And what we're expecting is that we will have the updated package.json inside our dist folder as well. Let's see. Yay, we have schematics. Awesome. So what's left is to run some kind of end-to-end test. And I have some test app, which is just a regular Angular application. And in order to test our library, I'm going to run the ngadds command. But obviously, I can't type ngadds catchy name because the library is not published to npm yet. That's why I'm going to go to the local library, to the dist folder, and what's important is that I should point to the collection JSON here. Okay, I'm running this now. I'm installing the library itself from npm. By I mean the Angular CLI. And then I have updated the package.json and the app module. Okay, let's see what are the changes. Cool, that's our package.json. We have added the catchy name library. And in our app module, we have imported the catchy name module and actually imported it inside our app module, which is pretty cool. Okay, I think that was it. Let's go back to the slides. And I'm gonna share the URL to that repo later. I hope it works. You can actually get it from here if you see the URL, and I'm gonna make sure to make it public. Cool. Now I guess I gotta check if I have some questions. If I figure out how to do that. Okay, let's go to Q&A. Hi. Okay, we don't have questions, so if you have any questions, you can go ahead and type them. And if you don't, I think we're finished, right? Okay, cool.
Yeah.
So if you have questions at any time, you can find me on Twitter, I guess, or something like that. And I'm always happy to chat about Angular, schematics, or whatever.
Okay, so Mira, again, thank you so much. Thank you guys for participation, and well, have a nice evening then.
Thank you.
Yeah, thank you.
Bye.
Bye bye.